Okay, so we're just going to do a short video on how to change the BIOS battery in an E-series controller. So this is an E-series controller, so the first thing I'm going to do is make sure I'm ESD grounded out. So I've used an ESD strap and make sure I've grounded out. I'm then going to remove the controller by the 4 set screws that are in here. So I just need an M10 socket. I'm just going to loosen those off so I can gain access to the back of the controller. So now I've removed the 4 bolts, what I can do is just remove the safety controller, flip it over so I can gain access to the battery. Right. So that's where the battery is. So I'm just gonna So now we've got the replacement battery, we can then put it into the safety control board. Like that. And then basically now we're just going to do the reverse of what we did before, which we're going to actually put the safety control board back into the controller. But we just need to make sure that when we put it back in, we take good care that we don't actually hit that transistor there. So once the cables are reattached, now we can put it back into the controller. Like I say, we just need to make sure that we are careful around the back of that transistor. Okay, now the safety controller is back in place, we need to plug in the teach pendant and then use 2 cable ties for the strain relief so it doesn't pull and strain the cable. Okay, thanks for watching, we'll have another video shortly.
here again for Cobot Weekly. This week my guest is James Douthwaite from the University of Sheffield. Hi James.
Hi Mark.
James, can you tell us a little bit about your role and what your organisation does?
Yeah, absolutely. So my name's Dr. James Douthwaite. I'm a researcher for the University of Sheffield. I'm personally involved in projects across the AMRC, the nuclear AMRC, AMRC Cameroon, on topics of digital twinning, collaborative robotics and industrial safety.
Excellent, excellent. How can research hubs like the AMRC and the universities help companies with the adoption of collaborative robots into their factories?
Oh, it's an interesting question, isn't it? Yeah, so as part of what I've been doing more recently is trying to get exactly that question. Is trying to appreciate and understand the distance between a lot of the challenges that we're facing in the industry from the academic perspective, but to also better frame research to help us tackle those problems in a meaningful way. And how can we help? Well, what we're helping do at the moment is creating awareness, education on many of the different subjects that are involved in our industry, but also encourage funding into the sector, and also create more excitement about various topics between the different elements that we're looking at. And it's an exciting time to be involved in robotics from all sides, I see.
I think it's two important things, isn't it? To encourage enlightenment about that, so that the funding is put into that sector, and also increasing the skills, because as robotics grows, we need more and more people to be able to program robots and actually install robots. So that's an important part of that.
Oh, precisely. Yeah, absolutely. There's a skill set of this absolutely as well. The university is obviously primarily an educational institution, and research being so closely related to education, we're able to reflect themes from research directly into education, generate excitement as people move through the education pathway and start considering careers in industry and academia, all within the world of robotics.
Excellent, excellent. And what sort of tasks are being automated sort of quicker than others? Are there particular areas that you're seeing this being adopted sooner rather than later to maybe fill skills gaps or?
Ooh, yeah. Well, I think it depends greatly on the area that we're looking at, because I think there's, from a high level view, the world of robotics can be broken down to many different areas, and some are more amenable to the robotics industry, and some have many years away from being directly applied. So again, something I'm personally involved in is trying to find those potentially low-hanging fruit, and shortening the distance by identifying and even quantifying the pathways that those programs can take, but also help students come along that journey and prepare for a career in industry, but also bring new skills to the table as well.
And that's the key, isn't it? Those pathways, once you can identify those, we can guide people down those pathways to make it easier to implement the robots into their manufacturing sectors, if you like.
Yeah, I think it's something that's not really given, it's given a lot of attention, but it's not necessarily framed in the way that I feel like it should be. Yeah. And I get this from a lot of feedback from different projects that we're involved with, but also mainly from people in the industry who feel that things should be done slightly differently. But what I mean by that is that emphasis can often move on to things that aren't directly applicable in industry right now, but industry of tomorrow.
Yeah.
And helping understanding the value right now is something that's very important. And what we're trying to do right now is basically
change the agenda really to make it move forward at a much quicker pace, I suppose, isn't it?
Yeah, exactly. Bring those values to the front of the queue,
so
that we can frame the research and the educational pathways that that come from that research and celebrate that research in a way that industry can see as amenable to themselves and their productivity.
Exactly, because you're going to help them avoid the pitfalls of long development times, because you'll have already done a lot of that research and be able to present that to people, to sort of help them boost their or shorten their installation time so that they can actually see the benefits quicker. I guess that's the main crux of it, if you like.
Yeah, that's a good point to raise. It's coming to answer the original question. Is that a lot of the themes of research are looking at that deployment time, looking at the system as a whole, and understanding the challenges, not just with respect to productivity, with effectiveness, but also with respect to the overall capability and the flexibility of that system, but also understanding about how we can use things like new technologies from the world of IoT, from digital twins, and more collaborative technologies like universal robotics technologies, to create an environment that moves away from the traditional industrial platforms locked away behind closed doors into what we call the factory of the future, which is more versatile, and more attractive to upcoming generations of students.
Oh, excellent, excellent. One of the things that we get asked about smaller manufacturing companies are particularly prone to sort of labour shortages and staff retention. It's one of the things that how collaborative robots can be used to sort of help fill that gap. Are you seeing that in your research, talking to companies as well?
Yeah, I've been asking myself this question as well recently, because I think the role collaborative robotics play in this is seen differently from research and from industry as far as I can see it. But quantifying how is a little bit challenging, because I see it from a small company point of view. It represents an easier on-ramp, an easier to the robotics industry, but also a way to approach and trial robotics without investing in the large-scale equivalents.
Yes.
Because obviously that represents a potentially huge upfront cost to invest in a large manufacturing.
Probably cost and time, I guess, as well.
Well, yeah, and expertise and
yes.
stuff like that too, and the training requirements, the whole party. But from the academic side, it gives us a way to interface with industrial problems from an approach where we can expose students to this and generate impactful research studies that are actually testable and safe to interact with.
Yeah, and one of the things you touched on earlier was quite interesting is how can digital twins help companies of all sizes really sort of evaluate whether collaborative robots is for them?
So this is now I was talking, because digital twins is my bread and butter. They represent the next level as far as I'm concerned when it comes to creating contextually aware collaborative robotics applications.
Yeah.
So what this allows us to do is to move beyond traditional robot does job to robot finds job. Robot is aware of the process as a whole and therefore appreciates its position in the context of that application. And what this means is we can look at things like safety beyond the context of the individual robot. And what this means is we can start looking at things productivity-wise beyond the individual system and that creates a lovely interface for companies to also approach the collaborative robotic process and understand things like productivity, understand things like what it means to have humans and robots in the same process, but also look at things like cycle time for the individual robot, for the process as a whole as well.
It's interesting because you can't improve on anything until you actually measured it, and a lot of people haven't actually mapped out their process.
Yeah, well, this is exactly something I've seen going around and speaking to companies across the UK, is that like understanding that initial reference line, like how productive I'm being right now, is already a challenge, especially when quantifying return on investment, when looking at how should I invest in this and what kind of productivity gains will I see. And from the people I spoke to, people have seen a huge shift from when they actually take the plunge, but it's perfectly reasonable to say that there's a lot of risk up front. It represents a big investment. So some of the people I spoke to have ranged from 500% to 20%, depending on the application that they're looking at in a single task. And there's an exciting, real opportunity there.
I think it is a real opportunity for people to trial something out and de-risk it before actually making that first step and implementing it into their factory, isn't it? And I think that's what's exciting for people, having that kind of interface where you can trial a digital twin of a process without actually getting a robot on your factory floor and starting to take apart your machine and so on. It's kind of I think that's quite attractive to people, isn't it, for the future, is that could we drop in CAD models of what we've got here and look at cycle times, and you could tell us how much that's going to improve, then that's a bit further in pushing us down the road to make the decision, yes, this is for us and this is how quickly we could get it implemented. So it's a quite interesting concept, I think.
Yeah, I think one thing to that is that you're right to break it down into, there's difference when dealing with digital twins in the robotics space. There's pre-installation value and there's also post-installation value, but there's also end-of-life value. With robotics and introducing the technology to the marketplace, is that the pre-installation value and the installation value have to be super clear to make that risk worth accepting. And what I'm looking to do is how do we sail that mountain? But digital twins represent an opportunity to make that super clear, to help us show the risks up front, try things out, as you said, simulate and get sample results before that is commissioned.
Yes.
But also quantify things that might be a little more nebulous, like safety concerns,
Yeah.
projected costs, projected valuations, and even risks themselves.
Yes.
Yeah.
One of the things I was going to ask about, with your interactions with companies that you've currently had, is there particular areas that you've seen? You mentioned skills deficits, where there are areas where robots can help fill those skills gaps. One of the sort of anecdotal things that we've been asked about is like welders. You know, there is a shortage of welders in the UK, but is there any other areas that you've been seeing in research where robots can help fill that skills gap?
Oh, I think there's the dark, the dank, and the dangerous. That's the tagline, isn't it? I think yes, repetitive tasks.
Yeah.
That come up in every aspect of manufacturing, like a lot of them. Things like grinding.
Yeah.
Things like welding. Things like cutting and manipulation. Obviously, these are traditionally tasks that have been done by people, but they're not particularly necessarily a job that people would want to take on long term. And there's
because there are risks attached to those jobs as well, aren't they? They might be really noisy or vibrations and so on. So
there's been studies that show like a prolonged exposure to vibrating tools that causes nerve damage, and it's also it's also a necessary and valuable task that's often mission critical. So it has to exist, and that's where robots they can take that away.
It's one of the things that we get asked about quite a lot, and it's actually a byproduct of putting robots in there, is that you're actually increasing staff welfare because you're not exposing them to do those kind of tasks that are horrible or tedious that nobody wants to do.
Yeah.
And that's the big sort of negative connotations about robots taking jobs. Is we always say robots take tasks and take the horrible tasks away from operators, and your staff welfare and retaining those people is the most important thing, I think, that companies need to consider, because retaining staff's a big problem, as we've discussed.
Yeah, I completely agree. It allows you to redistribute your skills in a place where they're needed.
Yes.
Yeah, because that task is essentially holding a company back in some respects.
Yeah.
There are skills and precious resources that person represents that the company cannot lose, and so you better put them in a place where they're more appreciated.
Yes, so they're going to stay.
Yeah,
that's the thing.
Exactly.
One of the trends that we're seeing is the combination of like a 6-axis robot arm on the back of an AGV, and that might be tending a process like a laboratory process or whatever. Do you see this expanding as a trend for the future?
Oh, I think so. There's a couple of barriers though. Yeah, and I think and the main one being safety.
Yeah.
I think is the one that it's a repeated theme both on the academic side and on the industrial side, is understanding. Well, I should one step back. Is that when you're talking about mobile processes, there's a prerequisite for a greater understanding of the environment that robots operating in, and understanding of the variability and of the human role. A lot of the work that I do focuses on the human-robot interaction element of this, but for the purpose of assessing risk. When you have a 6-axis robot arm, you can, stay safe by stepping away.
Yes.
But mobile robots, you need to make sure you know where they are and what the procedures are for handling a dynamic environment. Yeah. But mobility is a huge selling point for robotics, and as we're seeing this all over the industry, as far as from my experience, as things move away from a traditional industrial static manufacturing line,
just in a fixed position,
with the barriers that is robotic, we are not, for safety reasons obviously, to one that is shared, which is exciting because it gives us, first of all, on the academic side, much more interesting case studies, but an industry productivity that we've not seen before.
It kind of opens up task groups that we would never have considered, like taking kits of parts to production lines and so on, which is something that's not a real value add task, is it? There's a lot of people are just involved in taking things from stores to production lines and back again, and that's perfect sort of application for a robot on a guided vehicle to go and pick those and bring them to where humans are using their skill to assemble something. So.
Absolutely, and there's lots of technology that's coming down the pipes from academia and from industry as well that are helping these technologies get into the spaces where they're needed. Because it's quite easy to identify a task such as grinding or welding as a repetitive but necessary task. But it's difficult to identify tasks such as logistics. All you're doing is moving potentially a heavy weight or sharp component from A to B.
Yes.
Very amenable to robotics.
Yes.
And again, automation can be useful.
One question that I was going to ask you about, how do you think the development of end-of-arm tooling is going to help with the adoption rates of robots generally in the UK? Because we talk about the robot just being a platform, basically. You're moving something between two places, and that might be a rotating tool or a gripper or something like that. But it strikes me that that's the next big thing that's going to open up robotics, is having much smarter tooling to be able to pick and place and react to the environment that's in. And you touched on it a little bit earlier about having robots that kind of understand the environment that they're in. But I mean, do you think that would have a big effect on how usable robots are in industry?
Oh, certainly. I mean, as we move towards this sort of more hybrid, more shared spaces we talked about, there is a necessity there to ensure that when they do interact, that you're not going to, reducing the risk there as
yes.
well. We're obviously picking things up requires putting them down and eventually exchanging them with people. For that, we need grippers and effectors that will, support that kind of level of interaction,
yes.
but we're not compromising on effectiveness. I'd also raise the standardization. That's one of the elements that I think is something that you guys here at Universal have done exceptionally well. Is help us bring a more regulated and more understandable ecosystem.
Well, like the UR+ scheme that we have, yeah,
exactly, and it helps us in research and in academia basically assail new tasks and work out whether or not the robot and the effector is right for the task at hand.
Yes.
Yeah, it's an interesting element, but there's a couple of elements to play in this scenario.
Yeah, some considerations that we need to take into account before developing end effectors that might be revolutionary. The safety obviously is a big aspect of that, of course.
Yeah.
How are cobots being used at the university for research? I mean, they're being used in lots of different departments, but we see them used in academia in different organisations in the UK. I'm interested in the sort of things and why you would use the UR robots as well. I mean, are they particularly easier to program and live with, or are they more sort of like open source than other robots?
So it's a great question to ask, because one thing, the main reason I guess is because of how open UR is to the academic community. It's one thing that makes approaching education programs and research tasks particularly easy, because the integration step is formidable with most systems. But when designing a new case study, we have to do time planning. We have to understand the technical requirements up front. And the way we do that is we look at what's available in the industry. We look at not with respect to hardware, but also with respect to the software that comes through, which is a critical element.
Yeah.
And for a lot of large companies, that software support and the openness is not necessarily upfront, and transparency is key. I believe personally, the transparency is key for adoption in general, but especially in academia.
So it kind of makes it easy to live with, I guess, to have that openness in the software, I think.
Oh, absolutely. Yeah, it's something that I think needs to continue to be developed and echoed by many robotics companies.
One thing I was going to ask you about, do you think there needs to be a change in, we talked before about pathways for education to train people to get into robotics, whether it's like an apprenticeship in robotics, similar to like an engineer or an electrician? Do you think that would be a good idea for the economy to sort of set up these kind of roles, if you like, to be trained for? Because generally robotics programmers have come through a kind of university course. Do you think there's an opportunity to run parallel to that, maybe a more practical course perhaps?
I mean, I think so. So on our side, it's a question of funding and ownership, like who's doing it and what it yields to the university's portfolio. Yeah. But the skill set and the direction the UK's manufacturing sector is going screams that this has to be at the forefront. Because robotics will soon be a skill set that many people in the sector should have, and companies will be looking for, because as we know, the manufacturing sector is becoming slowly more automated. I mean, we're lagging behind G7 as we've talked about in the past. But if we hope to catch up and become competitive on a global scale again, it's the way the industry has to go.
I think there's only one way to do that, isn't it? Be innovative, and we've always done that in the UK. We've sort of grasped innovation, and I think
We're good at it.
yeah, we are. The opportunity is great for us to make that leap. I think in the next sort of 5 to 10 years, I believe. And one last thing I was going to ask you is: are there any developments that you're working on that you think would be important for people to consider in sort of robotics generally at the moment with regards to your research?
Okay. Yeah, I'll keep it short. Yes, so I'm involved in multiple projects across the university and the different capital centres we work with. As I mentioned previously, we do a lot of work with digital twins, but specifically orientated towards the gap between academia and industry.
Yeah.
And what I'm trying to basically do is help academia and industry communicate. Transparency, as I mentioned before, being king. And we're doing this by engaging different capital centres as a way of test driving new pipelines, and whilst engaging in industry to help us understand what the true pathways are to narrow down what is the value and how do we get that value up front, and bring that to a point where it can be appreciated in industry and used to ultimately get more grant funding to do exactly that. So the research projects themselves, I'm currently involved in this is called the Twinality project. What this is a collaborative robotics platform that enables safety to be deployed on an application level. And we think this is really interesting. We're using this to basically take collaborative robots and apply a level of safety that extends this in a way that companies can basically do this offline or online, and understand the risks up front and help them quantify with things like return on investment, but also understand the training requirements and needs, and put them in contact with the people who know the best.
And that'll accelerate adoption, presumably. That's the whole aim of this, I guess.
Oh, absolutely. It's something that you and I obviously share as a value up front. Is this, from my perspective, to increase this adoption, is that it's transparency from end to end.
Yes.
But it's obviously a very serious industry. There's lots of technical requirements, but also human requirements too. And we need to make sure that everything's considered and no compromises are made along the way.
Well, thank you, James. That's all for this episode. Join us next time. We'll have another guest and we'll talk about the world of robotics.